Additive Cipher. Additive Cipher is one of the ways of encryption. Additive Cipher adds a key stream to the plaintext.
Let's take Alice and Bob as examples to explain Additive Cipher. Here, Alice sends a message, "Hello Bob." This message is what we call plain text. Now, to encrypt this message to create a cipher using the Additive Cipher technique, we use a formula as shown. Here, P represents the plain text, K represents a key stream, and mod 26 is just the modulo of 26.
We take 26 because there are 26 letters in the alphabet, and we've assumed that the plaintext message will only contain these alphabets from A to Z. This way we can create a cipher text from the plain text. We'll see how to encrypt each letter in the plaintext using this technique soon.
Now, we know how to encrypt a plaintext message using Additive Cipher. But, how about decryption?
Well, decryption is done on the ciphertext generated during the encryption. To get the plaintext back, we use this formula to get the plaintext back using decryption. Let's see the encryption of plaintext in more detail. Consider that our plaintext contains only H instead of "Hello Bob." Now, in order to encrypt this H, we use this formula that we saw earlier.
We can see from this table that the value for H is 7. So, we substitute P with 7. Now, what about K? We can use a key stream value for K as we want. But, remember that the key used for decryption should be the same as encryption. Let's use 15 for K. Then, 7 plus 15 mod 26 would be 22. So, 22 represents our ciphertext for the plaintext H.
Now, let's see what is the corresponding ciphertext for value 22 in our table. We see that it is W. So, our ciphertext for the plaintext H is W. If we had more letters in our plaintext, we could have obtained the ciphertext for each letter in a similar way.
Now, let's see how decryption happens from the ciphertext. When the ciphertext reaches Bob from Alice, Bob's system tries to decrypt it. We have our ciphertext, denoted by C, as 22. Now, what do you think should we use for K? We should use the same key that we used earlier for encryption, which was 15. So, 22 minus 15 mod 26 would be 7. Therefore, 7 is our plaintext representation for the ciphertext.
Let's look in the table. What plaintext corresponds to the value of 7? We see that it is H, which was indeed our plaintext in the beginning. In this way, the plaintext sent by Alice was encrypted using the Additive Cipher technique and decrypted when it reached Bob using the same key. This key is very important. This key would only be known by Alice and Bob, and without this key, Bob wouldn't be able to decrypt the encrypted message sent by Alice.
We just learned how message sent by Alice is received by Bob. The plaintext message is converted to ciphertext and back from ciphertext to plaintext. But the plaintext we used was only the letter H. Instead of that, we could have entire message as the plaintext.
Here, the plaintext is "Hello Bob." We can create a ciphertext for this whole message by using the same formula on each letter. Doing that would give us this gibberish as our ciphertext.
However, when this gibberish reaches Bob, he uses the same key used for encryption by Alice to decrypt this ciphertext, and gets the original message.
Now, if an intruder tries to intercept the message when it is being sent from Alice to Bob, then he would only see this gibberish text. He wouldn't be able to decrypt it as he doesn't know what the key is. The key that we talked about earlier, which was 15 in our case, is shared by Alice and Bob only. In this way, Additive Cipher and encryption ensures secure messaging.
Last thing to note about Additive Cipher is that, Additive Ciphers are sometimes referred to as shift ciphers or Caesar cipher as well.